Greetings everyone. Our project is called Automatic Irrigation Forecasting using IoT. The aim of this project is to create a smart irrigation system that can monitor environmental conditions, predict water requirements, and automatically irrigate plants. This system combines IoT sensors, LoRa communication, and predictive analysis to improve water management in agriculture, especially in rural areas where internet access may not always be available. The problem with existing traditional irrigation methods is that they have several drawbacks, such as most farms follow fixed watering schedules, which often lead to overwatering and water wastage because actual soil conditions are not considered. Another issue is that different plants require different amounts of water, but many irrigation systems treat all crops the same way. Manual monitoring also increases labor and reduces efficiency. In addition, many existing smart systems require continuous internet connectivity, which is difficult in remote farming areas. These problems highlight the need for an intelligent and offline capable irrigation solution. Hence, the main objective of our project is to automate irrigation using real-time environmental data. The system predicts irrigation needs for the next 24 hours using sensor readings such as soil moisture, temperature, humidity, and light intensity. It is also designed to reduce water wastage by supplying only the required amount of water. Another important goal is supporting multiple plant types, since different plants need different moisture levels. Finally, the system is fully functional without internet connectivity, making it practical for agricultural use in rural areas. Our proposed solution uses IoT-based sensor nodes connected through LoRa communication. The ESP32 sensor nodes connect field data such as soil moisture, humidity, temperature, and light intensity continuously. This data is then transmitted using LoRa, which supports long-range communication with low power consumption. The predictive model then analyzes the data using evapotranspiration principles to estimate future water requirements. Based on these predictions, the system automatically controls the irrigation pump, reducing human intervention and improving efficiency.
System architecture. Our system consists of two main parts, the sensor node and the gateway. The sensor node is built using an ESP32 microcontroller. It collects real-time data from different sensors such as soil moisture sensor to measure water level in soil, DHT11 sensor to measure temperature and humidity, LDR sensor to detect light intensity. All this data is transmitted using a LoRa module, which enables long-range communication without using Wi-Fi. On the other side, we have the gateway system, which can be an Arduino or the Raspberry Pi. It receives the data through a LoRa receiver. The gateway processes the data and controls the irrigation pump using a relay module. It also displays system status using an LCD display. Let's move on to the key features. That is, our system is designed with several important features. Automatic irrigation. The system automatically turns the pump on or off based on the real-time conditions, eliminating manual work. Multi-plant support. Different plants have different water needs, so our system supports multiple plant profiles. Solar powered. The system can run using solar energy, making it suitable for rural and remote areas. Long range communication. LoRa technology allows communication over long distance without internet. Low power consumptions. That is, the system uses efficient components and sleep modes to reduce energy usage. Let's move on to plant profiles and working principles of this. Different plants require different levels of water. For example, paddy requires high water levels, tomato needs moderate moisture, cactus requires very little water. Our system stores these profiles and uses them for accurate irrigation.
Our system works in a simple automated flow. First, sensors placed in the soil collect real-time data like moisture levels. This data is then transmitted using LoRa, which is a long-range communication technology. Next, our model processes this data and predicts whether the plant needs water or not. Based on this prediction, the system automatically controls the pump. So the entire process from sensing to decision making to action happens automatically without human intervention. This ensures timely irrigation and avoids both overwatering and underwatering. We are not just reacting, we are predicting. Our system uses an evapotranspiration based model which estimates how much water plants will need based on the environmental conditions. The inputs include temperature, humidity, sunlight intensity, and soil moisture. Using these factors, the system calculates future water requirements. The output is a precise irrigation schedule tailored to each plant. Also, an important advantage is that everything runs locally. No cloud is required, so it works even without internet and ensures faster responses and data privacy. The system makes decisions in a structured way. First, it checks the current soil moisture level. Then, it looks at the trend to understand whether the soil is drying or stable. Next, it compares this with the predicted water requirement. Finally, based on both the current condition and the prediction, the system decides whether to turn the pump on or off. This approach ensures that there is accurate irrigation